So as in the last video we saw how k-means is also going to fail in some conditions or in some databases like this, in which you have to classify this in a unsupervised learning algorithm. So what we are going to use today is something we call DBSCAN. So what we are going to do is we are going to take a point like here. Let's suppose this is a point. Or let me do this right here. So let's suppose we have a point something like this. So what we are going to do is we are going to start from this part, and what we are going to do is we are going to find the distance of this point to the next point. Okay, now if this next point is uh, closer than some threshold, let's suppose if the distance between both of them is, let's say, less than 0.1, then these both are going to be considered in a uh, single cluster. Okay, then again what we are going to do is we are going to check from this part that if the distance of this from this point is going to is less than 0.1, then we can say that okay, this is also a part of this. Then again we are going to do the same, again we are going to do the same, and we are going to do the same until everything is over. Okay, so now what we are going to do is uh, this is how we are going to identify the first part. Now when the distance we find from this point to this point, or this point to any of this point, is going to be greater than 0.1, so what it is going to do is that it is going to consider this point into some other cluster. Okay, and now we are going to find these points, like okay, we will find the distance from this point to this point, and it is going to inside this cluster, then again this cluster, then again this cluster, and this is how it is going to identify all the points in this cluster. I hope that it is pretty easy, and this distance is a hyperparameter that you can give, and you can try to change its value to see which value gives you the best result. So let's look at the output of the DBSCAN algorithm. So what I'm going to do is I'm going to do from sklearn dot clusters import DBSCAN. Okay, it should be, I think, cluster. Yeah, so DBSCAN, and let's take a look at what DBSCAN takes as an input. So DBSCAN, so it take epsilon, and what is this? This is nothing but this is the maximum distance between two samples for them to be considered in the same neighborhood. So this is the maximum distance. So if the distance is greater than this, then they are going to be considered as two different clusters. Okay, and what is the minimum number of samples? So for some points to be considered as a cluster, there should be minimum of 5 samples. Okay, so there should be a minimum of 5 samples to be considered them as cluster. So this is what we are going to give. Let's suppose we are going to make the object like this. So DBSCAN obj equal to DBSCAN. Okay, and what I'm going to get, I'm going to get to obj.fit. This I have to pass x. Okay, so it has done this. Now what I can do is labels. I can get labels. So obj.labels. Okay, and what I can do also, I can also use this. So label is not defined. Okay, it should be label like this. So as you can see here, we got the values like this. So we have classified them without the use of 5. And how we can say that it has not used 5, because you can see here that when we use the fit method, we only pass the x, not the y, and we are using the labels that we got from this object. So this is able to classify them very good. Now what you can do is you can also use different kind of data. So let's suppose if what I am doing here, uh, okay, so let's give some noise here. Let's say noise is 0.5. Okay, so this noise is too much, so 0.1. So let's give this noise here. Okay, and now if we will do the dB scan on this part, let's see what we are going to get. So as you can see here, it did not uh, you know classify them as two clusters. So for this, what we can do is we can change some parameters. So let's say EPS is going to be 0.1, and as you can see here, right now it is considering it as 3-4 classes. So this is also not good. So let's change it to 0.2. Now it is not doing again, so 0.15. So now if you will see, it has considered them as two classes, mainly in two classes. So you can see, you can say that it is generating a good result, although there are some uh, outliers like them, but they are not going to matter that much because we have considered the overall output is very good. So I think that now you can see how DBSCAN is going to be very useful in these kind of cases. So this was it, and thank you for watching. I'll see you next time.